Hey everybody, I'm going to take some time to explain the XLT turbo project. So I'm going to go over the boost circuit right now. So what we have here, we have a GT15 Chinese clone. It is oiled by its own self-contained oiling system that has a reservoir down below. About 20 ounces of oil live in the reservoir. That reservoir feeds a diesel fuel pulse pump. That pulse pump is powered by a 12 volt rectifier off the lighting circuit. So that pump is always on when the motor is running. From the turbo, we have the wastegate. The wastegate currently is set at roughly 10 psi. From here, it flows up into a large volume plenum. That plenum on the bottom side has 3 outlets that match the spacing of the 3 Mikuni VM carburetors. Those outlets flow through 90-degree silicone couplings into the face of each carb. Each carb has the vents boost referenced back to the plenum, and also the slide tops are referenced back to the plenum. The blow-off valve on this side, located over here, is a manual blow-off valve set for 7 psi currently. The exhaust system is a stock exhaust system, 3-to-1 for the expansion chamber. The expansion chamber comes around the front, and then it goes into a simple reducer that is held on with springs that mounts directly to the inlet of the turbine for the turbo. Inside the exhaust turbine, there is, on the primary side, the wastegate that flows into the same cavity as the exhaust, and then the exhaust flows out through the side of the sled. Located here is a AFR gauge. Now I'll go over the fuel circuit. It has a stock fuel pump that feeds the bowls of each carburetor. It then has a secondary fuel system powered off of an M18 battery that goes through a buck converter to drop it down to 14 volts, then to distribution blocks located here for gauges and also the secondary fuel pump. The secondary fuel pump is powered off this buck regulator through a relay that is controlled by a Hobbs switch. This Hobbs switch in turn trips the relay to turn on the fuel pump that's located on the other side. This Hobbs switch kicks on at about 4 psi. My testing has shown that the stock fuel pump will provide fuel through the carbs up to around 5 psi of boost pressure. The boost pressure entering the plenum will actually go into the float bowl and force fuel from the floats up through the main jets, maintaining good fuel ratio up to about 5 psi of boost. When this Hobbs switch trips, it turns the secondary fuel pump on, which is an electric fuel pump located down on the other side. That fuel pump then provides fuel up to a boost regulated fuel pressure regulator that is set to 3 psi over current boost level. As the boost builds, the fuel pressure builds in the fuel rail that then supplies independent fuel to 3 power jets located at the entrance of the plenum for each carb. Some gauges that I'm running on this system is a EGT gauge. That's a digital EGT gauge that is powered off the M18 battery. I have an AEM AFR gauge that is also powered off the M18 battery. We have an analog boost gauge, and we also have an analog fuel gauge that is referenced off the boost referenced fuel pressure regulator. This is a automotive style analog temperature gauge for the coolant temp of the motor. This is a stock switch housing that has been modified to accept the RTD from the automotive style sensor. This is a live view of the instrument cluster with the power on. Here we have an EGT gauge. We have the AFR gauge actively reading. We have 3D printed gauge housings. We'll see how long they last. We have the boost gauge, and we also have the boost referenced fuel pressure gauge. Down here on the side, we have our standard Polaris ignition key. And then next to it, we have our accessory power switch and our secondary fuel pump switch. Above that, I have a prime, so I can force on the secondary fuel pump to prime the system. Down here, I have a bright blue LED that tells me when the oil pump is on for the turbo. And located here, kind of hidden, is a green LED and a green LED. These are active when the hob switch is on, telling me that the secondary fuel system is active. This is a view of the engine temperature gauge. To make the plenum work, I had to modify the pull rope guide with a simple little frame to offset it and raise it up. I also had to modify the brake line. Stock brake line has been replaced with a longer AN style brake line. No other modifications have been done to the fuel system or the cooling system. Here is a zoom in of the bottom of the plenum showing all the reference lines, that it is important that they are all the same length and go to the same common location for boost reference. You see the power jets in the face of each carb inlet. We made our way to the other side of the sled. This shows the back side of the plenum with the HKS blow-off valve, our fuel pressure regulator, our secondary fuel pump pickup and return. Off the back side of the plenum, we have our boost reference line going to the regulator. We have our boost line going to our boost gauge and our fuel pressure line going up to our fuel pressure gauge. Here is a zoomed in view of the bottom side of the plenum and the power jets. Here is a zoomed in view of the turbo. The oiling line, that is a standard AN line that has been cut, and high pressure silicone hose has been added for the oiling line. The reservoir, the fill for the reservoir, the vent for the reservoir, the turbo return back to the reservoir, and then down here is the feed out to the pulse pump that provides oil to the turbo.